So, hello everyone, and welcome to this weekend weekly session that we conduct. Ask AuxEn Anything. And as you all know, that this is an online session for civil structural engineers to interact with us and ask their doubts or queries that they may have related to RCC steel design project that they are doing, or any construction site issues, or any design concept or detailing concept where they want to discuss with us, which they want to discuss with us. So this is the 58th such session that we are conducting, and let us begin by taking the queries for this week. So first I'll take the queries from the Google form, and then we will take the queries from live audience. So let me just share my screen and let us begin. So let me just share the screen. Yeah. So the first question asked is by engineer Rajendra from Sangli. He is a working professional, and he is asking what are the important design parameters in StatPro for designing RCC building columns as per ACI 318. So although I have not used StatPro for ACI 318, right now we are doing a course which he is part of, uh, where we have done the RCC design using ACI codes, but there we are using ETABS. So I'm not very sure uh, about the design parameters that you need to give in stat for columns, but from my general understanding what I have, you will have to give some effective length factors. So some effective length factors will have to be given. Stat on its own does not perform the uh, stability index. Voice is not coming. Is my voice audible? Hello. Can someone in the live audience confirm? Is my voice audible? Hello. Okay, so now it is audible. All right. So the question being asked was, thank you. So question being asked was that what are the effective length factors that we have to give? So, or what are the design parameters that we have to give? So I was saying that in StatPro it does not do the stability calculations on its own, or let's say the sway factor analysis is not done on its own. So you may have to give the effective length factors. Effective length factors will have to be given Other than that, the reinforcement arrangement has to be provided in StatPro, that what sort of reinforcement arrangement for columns you are going to define, whether equally distributed on four faces or distributed on two faces only, two faces about the major axis or about the minor axis. So all those parameters you will need to give for columns. Other than that, I would say for columns, maybe if you are running the seismic provisions, some seismic related parameters may have to be given. But I would say overall, these days the StatPro, they have not updated their modules. So in fact, the StatPro still uses the ACI 31814 in its design program. So it has not even updated to ACI 31819. So what they are saying to the user is that if you want to use the ACI code, you just run the analysis in stat and then take it to RCDC. Okay, so in RCDC, they have updated, and you will get the all the uh, sway factor calculations, stability index calculations, plus you will also get the proper reinforcement arrangement that you can set up. So what I will say is that the analysis part you run in the stat, or you do it in the stat, and then take it to RCDC for the further design part. Yeah, one thing I forgot, P delta analysis also you need to run in the software. This StatPro is able to do well. So you run the P delta analysis, P delta with P small delta as well. So this is done properly in stat. So you can do that. And once the analysis is complete, then take it to ETABS. Sorry, then take it to RCDC for further checks. Okay. All right. So this was Mr. Rajendra with his query. Now the next query is from engineer Harish Acharya. He is from Bangalore and he's a working professional. So he's saying which method, he is asking which method is preferred to design the reinforcement in safe foundation. In safe foundation, strip based or finite element based. Based method is very difficult when it comes to irregular shaped footings. Correct. So strips you can only make when you have a regular, when you have got regular, let's say, column grid, when the columns are in proper line, or orthogonally placed. Only then strips are, I would say, easier to make. Easier to make means only then it will give you some meaningful outputs. Because otherwise, if the building plan is not, let's say, a regular shape, or if your columns are not properly in line, it is difficult to make strips and to get a meaningful sense out of it. So in such cases, you may go for the normal FE based methods. But in the FE based methods, remember that all these FE outputs, finite element outputs, are for each and every point. So uh, you may have to do some averaging. You may have to do some averaging of results, because in FE outputs you will see some local peaks. So averaging of results you need to do based on some engineering judgment. And if you are able to do that, then FE based outputs are good enough, because at every location strip based outputs may not be suitable or may not be possible. So whenever in safe, most of the engineers face this problem, that there are local peaks, and for that I'm saying that you need to take proper engineering judgment for it, do some averaging, and then take the results. Okay. All right. So this was the query from engineer Harish. Then the next question asked is, I hope my voice remains audible. Then the next question is from engineer Balaji. He's from Chennai and he's a working professional. So his query is, when we apply equipment load in PV structures, there are two types of load. They are giving static and dynamic. I can understand one is self weight, another is weight to vibration or movement. But how we consider this in StatPro? So this is not only for pre-engineered structures, but any building for which you are providing equipments. So generally, the equipment supplier, what they give you is the equipment supplier gives you a static load, and they also give you a dynamic load. So each equipment supplier, or for each equipment, you will get a static load and you will get some dynamic load. Now in static load also, they may give you some empty load. Okay, so by empty load means the self weight or the own load. Let's say if the equipment is some sort of a let's take it as a some sort of a rotating equipment where it takes in some contents and then it rotates. So there are some contents that get filled and then it rotates. So your equipment supplier will give you that empty load, then it will also give you the filled load, if applicable, that is. And then it also gives you some dynamic loads. So dynamic loads depends on the type of equipment or machinery, or if it's a storage kind, if it's a silo, or if it's a cylindrical structure for storage. It depends on the type of equipment, that what kind of dynamic loads are given. Types of equipment or machinery or container, they give you the dynamic loads. Now those dynamic loads can be, let's say if you have a impact type of machine, there will be some downward dynamic. Either they may give you some percentage, or they may give you some total downward load if it's an impact machine. If it's a vibrating machine, they may give you some horizontal, let's say horizontal translational reactions if it's a vibrating machine. If it's a rotating machine, they may give you some, uh, let's say, torsional twisting type of dynamic impacts. So depending on the type of machinery or container or equipment, whatever, they will give you the nature of dynamic load. Now how to apply it? So you can make two different load cases, as you rightly pointed out. Now there is no set rule to how to take all these things into consideration, but one of the ways could be that you make a, let's say, a static equipment load case, okay, and you make a dynamic equipment load case, and then you have your dead loads, live loads, wind, earthquake, etc., and then you combine the different load cases with different combinations. Clear? Is this clear? Yes. So, uh, see, some people, sometimes what happens is that the dynamic load includes the static load as well. Sometimes it may happen that the dynamic load includes the static load as well. Sometimes they give you as a separate entity. So it all depends on how the equipment supplier has given you these loads. But then you can make different load cases, and for each load case then you can make load combinations. All right, so this was engineer Balaji with his query. So these were the queries that were there on the Google form. Now let me just have a look at the email, if there is any query on the email. No query on the email. So now let us take the queries from the live audience. So let's see what our live audience are asking. So one of the queries is, the first query is by engineer Babu Sundara Raman. He is asking, how is the initial sizing How is the initial sizing of structural members in PEB? So he's talking about three plate sections done, that is flange width to web depth, any PEB vendor standard for flange. Okay, so how do they do the detail general sizing for three plate sections? Because most of the pre-engineered structures are made in three plate sections where you have a flange, a web, and another flange. So what is the general strategy followed? That is the query. So what most of the times the strategy that is followed is, and we have discussed it in our PEB course also, that for flanges generally semi-compact flanges are used. So the flange width to thickness ratio will be such that they get classified as semi-compact sections as per the table 2 of your IS 800 2007. And for webs, the general principle to be followed, or most of the pre-engineered suppliers follow, is that they will take the webs as slender, because slender flanges are not allowed as per the current revision of IS 800 2007, although now it gets allowed in the your NBC update. But if you look at the IS 800, they don't allow you to use the slender flanges. So semi-compact flanges and slender webs are allowed. There are certain rules given for slender webs, so slender webs are allowed, but flanges have to be semi-compact. So as per that, your width to depth ratios or width to thickness ratios are determined. Now general thicknesses that uh, you would like to give for your flanges would be 10 mm, 12 mm, 16 mm, 20 mm, or if it's quite a heavy structure, 25 mm. These will be your general thickness of flanges. For very light loaded rafters, you may go to 8 mm, but generally people don't like to give flange thicknesses less than 8. For width of flange, now generally it depends on the width of plate that you get in the market. So what we try to do is that in the open market you get a fixed width of your plate. It is usually 1200 or 1500 or 1800. So whatever flange width you try to finalize will be such that the wastage can be minimized. You understood? So by that I mean that, let's say if you are getting a plate width of 1500 from the market, just to take an example, if you are getting a 1500 plate from the market, so maybe you would look at flange widths of 150, okay, or maybe you would look at flange widths of 225 or maybe 200. So in 200 you will be able to get 7 full pieces and one piece of 100 will be left. Now this you may use as a stiffener or somewhere else. Or for example, if you are getting 1800 as the width, then maybe a 225 is also good, because from 225 you can get 8 equal pieces without wastage. So flange widths are usually determined by the plate width that you are getting from the market, okay. But generally the followed plate widths are flange widths are, let's say, 150, 175 or 200, 225 or 250, 275, 300 and so on. If I go to webs, then the web thicknesses or web depths, if you are going to provide in rafter, generally we go for tapered sections. So in tapered sections what we do is we vary the web depth, isn't it? Now the tapering is also done in a manner that I can minimize the wastage. So for example, if I taper it from, let's say, 750 to 450, let's say, all right. So what I'm doing basically, that from this one plate, this is the width of plate, let's say. If I were to taper like this, and if this was 450, this was 750, then what is the width I'm getting? 1200. So what I'm trying to tell you is that from a 1200 wide plate, I can easily create two tapers with zero wastage. So in using such principles, we can basically, or generally the PEB suppliers determine what sort of tapering may lead to minimized wastages. Are you with me so far? What I'm trying to say? So the web depths, if you are going for a straight web, then again the same principle, that depending on the plate width, if you're going for a straight web, let's say if you have 1500 plate wide, maybe you go for 500 web thicknesses, web depths, so that you can get three equal pieces, and so on. So web depth, the web thickness, web depth, that is how you decide. For the thickness of web, generally we do not go less than 5 So 5 6 8 10 if it's a very heavy utility, 12 these can be the thicknesses of webs that you take. And then of course we provide stiffeners for the web. So those stiffeners may be 5 or 6 or 8 stiffeners. So this is how the general sizing is done, or the general initial sizes may be selected based on these principles. The main principle remains that we want to minimize the wastage as much as possible. Okay. The next query is from Engineer Magaj. Since we provide alternate bent up bars in slab, apart from that, do we need to provide additional torsional reinforcement at the corners? Yes. The code clearly says that the torsional reinforcement is in addition to whatever flexural reinforcement you are providing. So even if you are providing bent up bars, whatever bent up bars in whatever arrangement you are providing, in addition to that, your code quite clearly says that you have to provide torsion reinforcement at the corners. And because remember, torsion reinforcement has to be provided both at the top and bottom. And then it says you LX by 5 or whatever. Okay. And I think 3/4 of maximum AS. So this is an addition to any flexural reinforcement that you're providing. Got it? Okay. Then the next query is from engineer Suraj Nayyar. How can we apply crane load in ETABS? I mean, the same manner in which you apply other loads. What is the, uh, what is the doubt over here? The same manner in which you apply your general loads in ETABS. Same manner you apply your crane loads. First, you need to calculate the crane loads. So first, calculate the crane loads, and then after this, once the crane loads are calculated, if you have calculated them as point loads or whatever, then apply it in ETABS in the same manner. Make load cases for cranes, and then once the load cases are made, put them in the load combinations. Just hold on. Yeah, so just the general process in which you do. He's asking, I mean to ask, moving loads can be applied in ETABS. I have not tried myself, but I'm sure there must be some way to apply moving loads. Although I have not tried it myself, but so there is a process to apply pattern loads, but is there a process to apply point loads as moving loads? I'm not sure about it, but I guess there must be some way, but I have not explored it myself. Okay, yeah. Then next query is from engineer Magaj. By changing the load cases to non-linear, uplift is not coming. while it is showing uplift in linear case. What could be the reason? Because in non-linear, if you set it to non-linear in safe, I'm assuming, and if you press allow uplift, in non-linear case there is an option to allow uplift, then what will happen, that wherever uplift is coming, it will make the pressure as zero. So wherever there is an uplift, it will make the pressure as zero, and in the remaining portion which is not under uplift, it will increase the bearing pressures. In the remaining portion, it will increase the bearing pressures. Okay. So if you run a non-linear case, and if you allow uplift option, then uh, it will make the zone or portion of the footing where the pressure is uplift to be zero, and it will increase the pressure in the other regions. So that is the reason why uh, the software is not showing you uplift, because it has made it as zero. Okay. The next query is from Captain Cool. Which software can we use to do reinforcement detailing? So, reinforcement detailing you can do using manual methods. I'll prefer this to be the best way, because there are many variables or many criteria that you have to consider, and none of the software can give you a good enough uh, result. So it is best if you do the reinforcement detailing on your own, by taking the decisions as per the site constraints or site requirements. If not, then you can use the detailers available in etabs and safe. So there is a CSI detailer available. There is a detailing module, in fact, in etabs and safe. I have tried it briefly, but it's not very effective. There are not too many options that you have. Other than that, RCDC is a really powerful tool. So if you want to do the detailing, RCDC is quite powerful, because uh, because it has a lot of inputs and a lot of options, and it offers a lot of flexibility to the user. So RCDC you may use. Once you run the analysis, maybe you can take the model to RCDC and then do the detailing part over there. Okay. The next query is from Engineer Magaj. In PEB buildings, do we provide ties for pedestal? If not, then what will be the effective length factor for pedestal and PEB column? Mr. Suraj is asking, is RCDC accurate in results? Yes, it is. We have done one course on RCDC where we have explored uh, in depth all the things RCDC is doing, and it does a good job. Yes, so RCDC does a very good job. You may use RCDC for your projects, uh, provided all the inputs you are giving it appropriately. It does a good way. It does a good job. It has some problems for steel structures, which is having column concrete pedestals. Over there, it has some bugs, but otherwise, it's quite good. Yeah, so Mr. Magal is asking, do we provide ties for pedestals? So see, in PV structure or in any shed-like structure, what happens is that you have the shed width, and generally in this is, let's say, the span of your structure. So your structure will look something like this, maybe. Yeah. So no internal column, let's say, and so this is, let's say, 20 meters, and these spacings are whatever 7.5 meters. So in this direction you will have beams, tie of beams is there, plinth beams or ground beams or whatever. So in one direction your column pedestal is getting a tie, in the other direction you are not having any tie in this direction. Sometimes we provide slabs over here. I mean, there will always be ground slabs, So in some cases, some designers they try to cast the slab integrally with the beam and column over here. So they say that effective length, you will get the advantage in shortening the effective length because of the restraint provided by the slab over here. In some cases, if you're providing floating slabs, that means slabs not connected to the column or beam or pedestal or beam. In such cases, about one axis, let's say, you can take, assume it as a cantilever. So let's say if this is my x axis and this is y axis. So the unsupported length about the x axis, you assume it as to be cantilever. So you may take it as two times the pedestal length. And about the y axis, you are getting tie of the plinth beam or ground beam. So accordingly, you can uh, take uh, take the effective or unsupported length. Clear? But it's not a concern because what happens is that the generally these pedestals are governed by the column size, steel column sizes. So steel columns are large, and then you have the base plate, and then you have to leave the gap for base plate. So the pedestal size that you get usually, and it is oriented, most of the times it is oriented like this. So even if you have to take two times the unsupported length as the effective length about the x axis, it's not a problem because you get such a large dimension over here. So it's not a problem as such. Yeah. Uh, Captain Cool is asking any course on WTP, STP plant design? Not on plant design. We have not done any course on hydraulic calculations or plant design per se, but we have a very good course on liquid retaining structures. So over there, we have dealt in detail with the design, structural design and detailing of uh, structures which carry liquid loads. So tanks, multi-compartment tanks, okay, then circular tanks, on ground, underground, above ground. Then we have also in this course we have also dealt with the uh, hydrodynamic load calculations as per IS 1893 Part 2. So this course is very good if you want to learn the structural design of liquid retaining structures. The hydraulic design or the capacity calculations we have not covered. So this course we have done as per the IS, which is the code 3370, the latest 2021 limit state based code. Is it 3370 or what is the code number for liquid retaining structures? Yeah, 3370. So you may wish to take a look at this course. It's a good course that we have done. The next query is from uh, okay, so we how to purchase the course after filling Google form. I'll send you a WhatsApp link right now. You contact me on WhatsApp. Okay, I'll guide you. You send me a message on WhatsApp. I'll guide you over there. Any other questions? Any other query, question? Okay, so we have taken all the queries from the Google form. We have also taken the queries from the live chat. I'll wait for a couple of minutes. If there is any further query, we'll take that up, or then we will close today's session. Yes, anyone wants to ask anything else? I'll wait for a couple of minutes. There is one question being asked by Engineer Akshay Thakur. If full raft has if full raft has lift pit in between and it requires a fold, so how to capture that in safe software? So I think he's saying this is a raft and it has some lift pit. So how to capture? So one thing you can do is that you do not model this portion of the lift pit, keep it as an opening or keep it as unmodeled, and let the software analyze it, considering there is no raft over here. The second thing you could do is that in your raft, let's say if this is the portion of lift pit, you have the slab modeled or you have the raft in the lift pit also modeled, but then assign slab edge releases, because over here due to the level difference this may not fully behave as a rigid connection. The raft at this upper location and the raft at below location may not behave as a rigidly connected element because of the level difference. So assign edge releases on all the edges. So these are the two things you could do. Either you just remove this lift pit slab from your model, or if you want to keep it in the model, assign slab edge releases. Okay. Yeah. So anything else? All right. So I think there are no more queries. So as you all know that throughout once every week we conduct this session, and if you have any queries. Okay, Mr. Magaj has one query. If raft is completely covered, is covering all the plot area, even though SBC is not satisfied, even then the SBC is not satisfied, what to do in this case? What his question is that, let's say this is his plot, and because of whatever his column position was, raft he has provided, and now the raft area cannot be increased any further. So basically your total load upon total area, this is the bearing pressure, and because your total area is restricted, you cannot increase the area any further. Your bearing pressure, if it exceeds SBC, if that is your case, now what to do? Because load you cannot reduce and your area you cannot go any further. What to do in such cases? So in such cases, either you try to increase the depth of your raft. So that means if you are taking your raft to a certain level, maybe you try to take your raft till a deeper level, because at a deeper level you may get increased SBC of the soil. That can be one of the options. If not, then the other option is that you may have to add piles. So adding piles then remains a good option. So generally in tall buildings, if you see, what they do is that your basement area is, let's say, limited, and the raft is provided on the basement area. But then beyond that, they will add piles because the bearing pressure is not satisfying the SBC criteria. So then you may have to add piles in such cases below raft. So it becomes a raft pile system. So it's a common practice that is adopted in such situations. Okay. So increasing the depth may not be a good solution. Increasing the depth and taking the raft below at a deeper level is not may not be a very good solution. So providing piles, integrating piles with the raft is uh, a frequently followed structural arrangement. Okay. All right. Yeah, so once every week we conduct such sessions and the Google form remains the same. So whenever you have any query, you can just put the question in this Google form. I'm just putting it in the live comments. And when we meet once every week, we will take up your queries. If you want to connect with us on WhatsApp, then you can click on this to connect with us on WhatsApp. I'll just put the WhatsApp link over here. Yeah, so this is the link if you want to connect with us on WhatsApp. Okay, right. Okay, good. Mr. Magaj is asking, so we provide SBC for raft and spring for pile both? Yes. Yes. In some cases, let's say if your soil is quite weak at the level where you are providing raft, then many designers they completely ignore the raft, because anyway they have to provide the raft for basement, let's say. So it is just a piled footing that they provide, and this raft just acts as a pile cap. Not, it does not take any pressures. But let's say if you get substantial, if you are getting substantial bearing pressures at the level of raft, then you may take the advantage of raft and piles both. So it all depends on what kind of strata you are getting at the location where you want to put your raft. Mr. Suraj is asking which are the other courses that you are going to conduct in future. So right now we are conducting a course on American code, RCC design, and before that RCC design as per ACI codes. Before that we had conducted a course on steel design as per the AISC, American AISC codes. In future we will start with the earthquake, a course on earthquake, revised earthquake codes, because from May 2026, I think that is going to be enforced. So we are planning to do this course after that. I was waiting for the IS 13920, also revised 13920, also to be launched, because only then it will make sense to have a complete analysis and design detailing course to conduct. Otherwise, just analysis part, conducting a course may not be, uh, I would say, the best way to do it. So I was thinking that let the 13920 also get published, the revised 13920. Then it makes real sense to have an EQ course. Yeah, S456 possibly may get revised in 2026. Let's see. So right now, they have the 456 committee has invited the comments. The draft revision is already out, and the comments on the draft have also been submitted. I think the deadline was last week. Maybe within 6 7 months they may bring up the revised code. Let's see. Okay then. So that's it for this session, and we will see you next time, next weekend. If you want to connect with us on WhatsApp, this is the link. And have a good weekend. And thank you for joining. Until next time, goodbye and take care.